Hello and welcome to this series of videos where we will be building a Node.js application. We will be building a link shortener to be more specific. So it's going to be a very simple application, which is designed in such a way that it's going to be very easy for even complete beginners to follow along. And not only are we going to be building this application using Node.js and the Express framework, but we are also then going to deploy this application onto AWS Fargate. And then we're also going to be leveraging different bits and pieces from the AWS cloud, such as the application load balancers, to make sure that we have a very solid architecture powering our application. So I hope you enjoy the course. As always, I'll leave a link in the description below for my patrons to have access to the written form of what we're going to be doing here today. So if it's more comfortable for you to follow this with a post after seeing the video, then the link will be in the description below, and also the source code will be available here for my patrons as well. Okay, so jumping right in. What are we going to be building today? Today we're going to be building a Node.js app using TypeScript, and what we're going to be doing is we're going to be building a link shortening service. So this is basically, I'm sure you've seen all over social media, whenever you try to post a link, if either Facebook or Twitter will always change that link to a shortened version, and this is exactly what we're going to be building today. So what we're going to be using, aside from TypeScript, is the AWS platform, and more specifically for the database, we're going to be using DynamoDB. And so there's a couple of benefits that TypeScript brings instead of normal JavaScript. First and foremost, it allows us to strongly type variables, which means that when we declare variables, we have to declare also what type they are, and this leads to a whole bunch of benefits and just generally less buggy code and cleaner code, where we are going to learn also how to structure a project in a way that's easy to read and maintain and test and debug. We're also going to be building these endpoints that are going to be basically listening to requests and reading and writing data to and from the database. We're going to be using DynamoDB, which is a NoSQL database, and we're also going to be using a library, which is a ORM, which basically allows us to access the database in a very object-oriented way, so that we don't have to be writing queries to the database. And at the end of the day, we will finish with a finished link shortening product that can be used over an API, because this is only going to be a backend application. So some of the prerequisites for this course is to have Node installed on your computer, a code editor of your choice. I'm going to be using WebStorm because that's my favorite code editor, but VS Code is a great and free option. Have Docker installed, and also we're going to be using a tool called Postman, which is basically to emulate API calls to our service. Okay, so once all of this housekeeping is done, let's jump right into the project. Okay, so I've already created a folder where I'm going to be storing all of the source code for this project. So go ahead and create a folder for this project, and then inside of the project, you need to initialize a new node project. So go ahead and enter the command npm init. Now, since we're going to be using DynamoDB behind the scenes, we need to run this command here, which basically downloads a local version of Amazon's DynamoDB, and we can run it locally to have basically the same thing that we would have in production running locally. Okay, so to keep setting up this project, we need to run a couple of commands. The first is npm install savedev TypeScript TS node. So this will install TypeScript and TS node onto our project. Next, in our project directory, we need to create a file called tsconfig.json, and we need to also paste these lines of code here. This is essentially just a configuration file. You don't really need to understand what it's doing here. Just copy and paste this, which also will be linked in the description below, and just use this file and make sure you call it tsconfig.json and put it inside of your project directory. Next, we need to install the project dependencies. So we're going to be hitting npm install --save Express, dynamoose, NanoID. Express is going to be the framework for our API, dynamoose is going to be this ORM that I talked about previously, and NanoID is just a framework or library for generating random IDs that we're going to be using for our links. Next, we want to install some development dependencies, so we're going to say npm install --save dev at types express at types node and nodemon. So basically types, whenever you see a types prefix, these are libraries that just make the traditional JavaScript libraries compatible with TypeScript. And then nodemon is a development tool that we're going to be using to run our API, and whenever we change the code, it automatically restarts the server. So we always have the freshest version running on our process. Next, open up the package.json file that was automatically created when you hit the npm init command, and make sure that your script section is as follows. Very, very important. We need these two commands to be here. So dev maps to nodemon src/app.ts. This is going to be the entry point of our app. And then tsc maps to basically just the command tsc. Alright, so once that's done, we can start to actually define the structure of our project. This is going to be fairly important. So first things first, create a src folder, and inside of this folder, create all of the different folders that you see here. So controllers, infra, models, routes, and services. And then create a file called app.ts inside of this src folder. So what are all of these folders going to contain? The infra folder is going to hold source code that basically links our infrastructure to our application. So by infrastructure, we mean anything that our cloud provider, so in this case Amazon, offers us for us to build our app on top of. So in this case, it's going to be our DynamoDB database, but it could be anything else. And it could also be other vendors, not only AWS in our case. Then models is the folder that's going to contain the code that defines our schema and the models that we're going to be using to basically store our information inside of the database. Services is going to be the code that basically links the controllers to all of the models and potentially other services in the future. And the services here are going to have one very, very specific task. So for example, creating new shortened links, or redirecting the user when we receive a identifier for a link that someone else is trying to access, for example. Controllers is going to be basically the code that receives requests and maybe validates them and then passes it on to the services. And finally, routes is, as the name suggests, just all of the code that's going to take care of routing the different endpoints to the controllers. So if we separate all of our code in these folders, at the end of the day, we're going to have very, very clean code, which is very, very easy to know where you need to look for files and which they. So if you're, for example, debugging, you'll be able to find the bug much, much quicker. Also, it's very important to separate your files in such a way, the most granular way possible, because it makes testing easier. So we're not going to be doing a lot of testing, automated testing in this video here, but we will in the future. Last but not least, you need to create the app.ts file, which will contain all of the code that basically starts running our application. Okay, so I've gone ahead and created a app.ts file. And here, the first thing that we need to do is we need to import Express and application from Express. Then we're going to basically define app as type of application is equal to Express. And here, we're already starting to leverage the benefits of TypeScript, where we define a variable and we assign a type to it. And this type is extracted from the Express library. We're also defining a variable port as well as its type of type number equal to 3001. Next, we're going to use a couple of middlewares that Express offers to us. So we're going to say app.use express.json and app.use express.url encode. These are basically for Express to be able to understand JSON requests. Out of the box, Express doesn't do this, so we need to add this middleware in order for it to process JSON incoming requests and then send the requests also out in JSON format. Next, we're going to write our first endpoint. So this is going to be on the root directory of our application. We're going to say app.get / and then we're going to create an anonymous function. So basically, we're just going to open up parentheses, say request or rec and res for response. And then we use the arrow notation to create the function inside, which is simply going to say response res.send and a text of OK. So we do this simply to be able to test this out quickly. And then finally, we're going to say app.listen, and we're going to tell it to listen to the port that we defined previously, so 3001. And here also the callback that we're going to pass is a function that doesn't accept any parameters with the arrow notation, and we're going to say console log app is listing on port, and it should say 3001. So now if we go ahead and run this, we need to say npm run dev, and we can see that our application is listing on port 3001. So now if we go to our browser and hit localhost / 3001, sure enough, we can see that our application is returning the OK that we tell it to return here. Okay, so as I said before, we'll be building our API in layers of code. Each layer will be built inside of its corresponding folder. This way we can structure the application in such a way that it's easy for us and potentially others, if we're working in team, to read, maintain, test. Infrastructure is what we refer to as the building blocks that we have access to on AWS, for example, but it could also be another vendor. So these building blocks are the pieces of infrastructure on our vendors that enable us to build our application. These could be things like databases, emailing services, queues, so on and so forth. The infra folder will contain code that ties different infrastructures to the app itself, such as the database. Hence, in this folder, we will write the code that connects our app to the DynamoDB database, for example. Since a project can make use of multiple pieces of infrastructure, I like to create a folder structure within infra that allows me to easily add and explain and expand the infrastructure I want to tap into the future moving along. So this is why I created a folder structure such as AWS inside of infra, then DynamoDB inside of AWS, and here we just have one file called dynamoose.client.ts. So go ahead and replicate this folder structure. So in the future, if we wanted to use another service from AWS, we could just create a new folder here. Or if we wanted to use another vendor, then we could just create a new folder for a vendor here. Okay, so go ahead and create the dynamoose.client.ts file if you haven't done so already. And so the first thing that we need to do is we need to import star, so import everything as dynamoose from dynamoose. And then here, we need to create a configuration that allows dynamoose to access the database. And in order for it to be able to access this database, it needs credentials. So depending on if we're in our local environment or if we're in production, these credentials will obviously vary. So what we're going to do is we're going to write an if statement, and what we're going to be evaluating if is the environment variable node_env is equal to production, then we will insert production credentials. So the way you access AWS services is you always need to provide a access key ID and secret access key. I'll explain this further along, what this means, and we will fill them up later. Right now, we don't really need them, but we're going to place this code already here so that we know that we need to complete this later on. And then for the local version, so if it's not production, we will simply basically say the same thing, but instead also we will be calling dynamoose.aws.ddb.local. And in this case, it doesn't really matter what you fill in here, because since it's a local instance, it doesn't really have credentials, right? So this is just dummy code here. And then we will be calling the local DynamoDB instance. And then finally, we always need to export whatever we are writing here. So in order for dynamoose that we're defining and setting up the configuration here, in order for this to be accessible to other files in the project, we need to export this so that other files can then import it. Okay, so moving on to the models. The models is the thing that's going to use this configuration from dynamoose that we just created in the info folder, and we're going to be creating two things here. We're going to be creating a schema, so this is the format of the data, the definition of the format of the data that we're going to be storing in DynamoDB, and the model. So the model will take the schema and create a object inside of JavaScript, which will basically make our life much easier when dealing with these things in code, because we won't need to write queries to the database, which is very, very handy. So go ahead and also inside of models create a folder called links, and then inside of links create link.model.ts and link.schema.ts. The reason why I create this folder links is kind of for the same reason that we did here in infra, which is if we need more models in the future, we can just separate them in their corresponding folders. Okay, so once you have link.schema created, import dynamoose from the dynamoose client that we just created. It's very, very important you do this, and you do not import it from dynamoose itself like we did here from the library. You need to import it from the file that we just created in dynamoose, because this instance holds the configuration that we just set up to access our database either in production or on the local version, whereas the library doesn't have that configuration set up. So next we're going to create a new schema. So we say const link schema is equal to new dynamoose schema, and here we create an object inside, and basically our schema is only going to contain two values. So we have the link key, which will be of type string, and we need to set hash key is going to be true. So this basically tells DynamoDB, since it's a NoSQL database, it's really a key value store. So we specify hash key to be true, which basically means that this is going to be the primary key, so to speak, of the document, and we will be searching by this key. So the next thing that we need to do is we need to open up a new field in this schema, and we're going to call it original link, which is going to be the original link or the original URL that the user tells us that we need to shorten. So what we're going to be doing is we're going to be storing this alongside with a shorter key, and then whenever we store this, what we're going to give back to the user is a short URL which contains this link key, and it should be much shorter than this. And then when someone tries to access our URL with our key, what we're going to be doing is just basically fetching the original link from the database. Finally, as always, we need to export default link schema so that we can import it in another file. Okay, so now moving on to link.model.ts, this is going to be very, very simple. We also, again, need to import dynamoose from our infra folder. Then we need to import the link schema that we just created, and we need to create a links model. So we say const links model is equal to dynamoose.model, and we pass it the name of links, which will also be the name of the table that dynamoose will create automatically for us in DynamoDB. And we're going to be passing into the link schema to this model. Finally, as always, we need to export default links model. Okay, so moving on to services. Again, we create a links folder inside of services to basically organize all of these services related to links inside of this folder. And here we're going to create two files, create link.service and redirect link.service. So this is going to be whenever the users are going to be calling our API to create a new shortened link. And this is going to be whenever a user is calling our short URL to basically be redirected to the original link. Okay, so now that we have create link.service.ts created, we need to import NanoID from NanoID. So this is going to be the library that's going to be creating the random IDs that we're going to be storing as keys to our original links. Then we import the links model from the model that we just created. And finally, we import document from dynamoose dist document. So we're going to create a new function called create link service, and this is going to be a asynchronous function which accepts a original URL, and we type it to be a string, and it returns a promise that eventually needs to resolve to a document. So this is why we import this type from here so that we can strictly type what the function returns. Next, let's set up a variable which defines how long our keys should be. And so we're going to say key length is of type number and is equal to 8. So our keys will be 8 characters long. Then we're going to set up a Boolean variable, which we're going to call keep checking for duplicate keys is equal to true. I'll explain this in just a second. And then we also, whenever we're calling this service, we assume, that we want to shorten links. So we need to create a new key for it. And we're going to say let new key of type string is equal to nanoid. So we're calling the library, passing in the key length. And this should return a random key of 8 characters long. Now, the problem is that although the probability of this library returning the same key twice is extremely small, it could happen. So what we're going to do is we're going to complicate this a little bit, and we're going to check whether this key that's just been created already exists in our database. And if it does, then we're going to be basically creating a new one until we see that the key generated doesn't exist in our database, right? So this is just a safety check to make sure that we're not overriding potentially a link that's already stored in our database. So we're going to say while keep checking for duplicate keys. Okay, so this is initially set to true, so this will initially keep looping. And we're going to say let link found with key, and we're going to try and use our model to get the key, to get the link from our DynamoDB by the new key that we just created. And we're going to say link found with key, okay? And as always with asynchronous code, we need to wrap it in a try catch. So if there's an error, for example, the database is not accessible for whatever reason, we should throw an error, basically. And now, if we don't find the link with a key, then essentially we just say that keep checking for duplicate keys needs to be false so that we exit this while loop. But if we do find the key, we need to create a new key because we don't want to override this. So we create a new key. This would still be true, so we'd enter this loop again and reevaluate to see if we can find a link stored with the new key that we just created here. And hopefully, this shouldn't really even happen even once, because these keys are so random and there's such a small probability of creating the same key twice that this shouldn't happen. But hey, this is a safety guard, and like that we can also program something a little more complex. Finally, we need to store this new key with the original link that the user sent to us once we know for sure that it doesn't exist in the database. So we're going to say return await link model.create link key of new key and original link with the original URL that the people sent to us to this service. Last but not least, we need to also evaluate, since this is a asynchronous code, if this fails, then we need to throw some kind of error. We're not going to worry too much about this just for now. And also we need to export default create link service. Okay, now for the redirect link service. So first we need to again import the link model from our models. And we're going to this time define a type in TypeScript. So we're going to be defining this link so that we can then type the responses that we get from the database in just a second. So the next thing that we need to do is we need to create a synchronous function called redirect link service, which accepts an ID. So this is going to be the key that we're going to be using to basically fetch our information from our database. And again, we're going to be returning a promise, which eventually should resolve to a link. So this is why we're typing the structure of the response here. And we're saying that what we're going to be returning once the promise resolves is a link, which is basically an object that has a link key and an original link, both of type string. Okay. Now we're going to start by writing a try catch block. And inside of this try catch block, we're going to say const link is equal to await link model.get by the link key of whatever people sent to us. or call whatever whatever ID or whatever link key that they're calling. And when we find that, we're basically going to turn this link into a JSON. Reason being is that whenever you use dynamoose, whenever it finds something from the database, it types it as a document, a dynamoose document. So what we're going to be here is converting it to a JSON and then casting it as a link. So like that, whatever this function returns is going to be this link that we set up here before, and then it will be much easier to use downstream in the controllers. Then also, if we do catch an error, then we're just going to throw the error, and then we need to export default the redirect link service, but also we're going to be exporting this link type that we created before. Okay, so we're almost finished. So now we're going to be working on the create link controller. So again, inside the controller folder, we create a links folder inside create link.controller and redirect link.controller. So first thing we need to do is we're going to import next function request and response from Express. So this is now, we're really going to be, handling the requests that the users send us. We also want to import the create link service that we just created. And we're going to create a function, a asynchronous function called create link, which accepts 3 parameters, request, response, and next, each typed with their corresponding type that we import from the Express library. So the first thing is that we're going to do is we're going to see what's the original URL that the user is sending us. So the way we do this is we declare a variable saying const original URL colon, or we type it as a string, and we listen to whatever the user is sending in their body of the request, and we're going to be listening to a parameter called original URL. Next, we're going to set what's going to be the base URL for application. So again, here we need to evaluate first if we're in production, then we're going to use our domain name. So this is my one. And if we are not in production, then we're just going to stick with localhost port 3001. So here we're going to open up a try-catch block in which we're going to say, first we're going to validate the URL that the people are sending to us, because they can essentially send anything they want here, but we want to make sure that it's a URL. So the easy way of doing this is to use the inbuilt function that Node has of evaluating if something is a URL. So we just create a new URL from whatever the user sends us, and this will fail if this is not a URL. So if it fails, we're going to create a new error and say invalid original URL, and we're going to pass it to a next function. So whenever you pass the error to this next function that Express gives you, then what you're doing is you're telling Express that there was an error, and it should basically just respond with an error to the user. So after we do that, if it doesn't fail that, then we know that this has worked. So we create another try-catch block where we're going to be basically saying new link is equal to await, and here we call the create link service with the original URL, and we also create a link object is equal to new link.toJSON. So this is, again, we're grabbing the link that we get from this create link service, and we're converting it to a JSON basically so that we can then say res.json, so response, send the JSON out, and we say shortened URL is equal to, and here we're concatenating 2 strings together, so the base URL, which we defined here, together with the link key, okay? And then the original URL is basically whatever the user sent us, but also we're using this retrieved from our DynamoDB database. If this fails, then we just pass the error onto the next function, and then, as always, we need to export the create link controller. Okay, so now for the redirect link controller, what we're going to be doing is we're going to import the exact same thing. So next function request and response from Express, and we are now going to be importing the redirect link service from our services, and we're going to create a new asynchronous function called redirect link, which is going to have the same parameters that it's expecting to receive from the Express framework. And then we can say const ID is equal to, or is of type string and is equal to request.params.id. So why params and not body is because this is going to be a GET request. And so we don't really have a body. We only have parameters that we can listen to that come with the URL. So we're going to be listening to what ID are they requesting, or what link ID are they requesting on the URL. So if you don't find an ID, then obviously this is incorrect. We need an ID, so we're going to create a new error, say missing ID, and pass it on to the next function, which will take care of it. Then we say so we define a variable called link, and we create a try catch block in which we say link is equal to await redirect service ID, and we pass the ID into this. So remember, the redirect service grabs the link by ID from the database, and then basically just returns it to our controller so that our controller can basically take care of the rest. If we don't find a link, then we're going to basically just say res.status 404. So we're going to return a status code of 404, which is saying that we didn't find the link. So this is if the service fails. So usually this would mean that the database fails or something similar. It's kind of arguable if we should, return a 404 or more of a 500 or something, because maybe it's a server error. We're not going to go into too much detail on status codes in this course, but I just chose to send a 404 for now. So again, if we don't find the link, so if the database worked, but we still didn't find anything in it, then here for sure we can send a 404. So we're saying we didn't find the link. Otherwise, we're going to say response.status301.redirect, and we're going to redirect the user to the original link that they sent us. So a 301 status is a permanent redirect. So this basically tells the browser that there's no content here. We're going to be redirecting the browser to this location here. Okay. And finally, we just export default redirect link. All right, so last but not least, we just need to tie everything up by setting up the routes for our application. So create a link.routes.ts file. So in this file is going to be very, very simple. We just import router from Express, and we're also going to be importing our two controllers that we just created. So redirect link and create link from our controllers folders. And then we're going to create a new router by saying const link routes is equal to a new router. And here we're just going to say link routes.get /:ID, and then whatever comes through this path, we're going to send to the redirect link. So if you see here, we're creating a parameter that Express is going to be listening to. So whatever comes after the /, if it's a GET request, whatever comes after a /, we're going to assume it's an ID, and we're going to pass it into the params here that we're picking up later. Okay. And then linkroutes.post, so if they do a post request to the root endpoint, then we're going to be calling the create link controller. And as always, we just need to export default link routes, and that's it. Now I'm back in the app.ts file, because there's just one more thing that we need to do, which is right now the app.ts is loading up, and it's basically just creating one endpoint, which is this endpoint that we created here inside of this file. So now what we have to do is we need to link the routes that we just created to this Express application that we defined here. So the way we do this is we just simply import link routes from the routes folder that we just created, and then we just say app.use and pass in link routes, and this is basically it. So our application is now complete. Let's go ahead and test it. So I'm going to go ahead and hit npm run dev again to start up our application. Okay, so we can see it's running. Okay, so I've opened up Postman, and I've created a new testing endpoint. So I'm going to be calling a post request on HTTP localhost colon 3001, so port 3001, and I'm going to be sending this payload here, right? So I'm going to be sending, original link is going to be google.com. I'm going to hit send, and sure enough, we can see that our application responded to with a shortened URL, and it's just informing me what's stored behind, so the original link that we sent, that's going to be stored behind this link. So now if we go ahead and I'm going to copy this, and I'm going to go into my browser and paste it in here. Sure enough, we should be redirected to Google, so we can see that everything is working, which is great. All right, guys, so I hope you enjoyed this very quick and simple course on how to get up and running with Node.js, TypeScript specifically, and AWS DynamoDB. So in this course, we haven't deployed our application to the cloud, so this is something that we're going to be doing in the next video in this series. In the meantime, please consider becoming a patron, where you will gain access to the written form of this tutorial. Where you'll have all the commands available as well as the source code. And if you like this video, please make sure you hit the like, so that the YouTube algorithm knows that you should share this with more developers like yourselves. And in the meantime, thanks for watching, and I'll catch you guys in the next one. Take care.